Okay, so I guess it's right now it's just me and you, Hazel. So let's go ahead and get started. And I think some more people will join, but if not, I'm going to record this and it'll be posted on our YouTube page. So, um, did you have any questions before we start the normal material?
No questions.
Okay. Okay. So this is one of our last meetings. I think we'll have this one, and we'll have one more just to kind of talk about the final. So, over here. All right. So last time, the last meeting, we talked about exponential smoothing. We talked about our Riemann models, and those are two things we're going to be using on the second project, which is due October 15th, along with the final. So there's this course. I structured it to only have kind of three big assignments: the first project, the second project, and then the final. And so the last two big assignments are due on October 15th. So you still got some time, but maybe get started on those when you get a chance. And last piece of material I want to cover today is on unit roots. And so your project 2 is going to consist of some forecasting of some time series and using your same stock market data. And I'll show you how to go with that. But everyone who selected, or everyone did select, two stocks for project 1. And so you can use the same two stocks to make it easy and just use that data to do some forecasting. Okay? I'll probably expand the data set because it's best to use the more recent data for forecasting because you want to forecast what hasn't happened, not what's already happened. Okay, so why don't we do a quick little lecture. Okay, so last thing I want to cover is if you go to our Riemann models continued panel data, your lectures. Okay, so I'm just going to cover the things that are relevant to the second project. And so last time I showed you to use a different software to do some of the forecasting, which was RStudio. And so if you were here last time or you watched some of the videos, you were instructed to download some software. So on Blackboard under software, for the second project, we're going to be using R, which we're actually going to be using RStudio, which runs through R. And so you'll need to download R for Windows or Mac, whatever kind of computer you have. So, and then download RStudio, which is the platform we're doing some of the analysis. And then today we're going to be using some features of the eViews student version. And I'll show you how to do that. We're using a couple pieces of software to do the second project. It's all free, but you will need to download some software. So the only issues would be, like I said last time, is if you have like a work computer, if there's any restrictions or permissions you need to download software, that might be an issue you'd have to work around. So if there are any issues downloading the software, we know it. I can help you with that. But we did some RStudio last time. We'll do some more this time, and then we'll also do a few things in eViews. eViews is very nice for a lot of regression and analysis. The problem is we only have the student version, and it's very limited in that you can't really save your work. So I just want to use a couple features on there which are useful, and then that's it. But there's the textbook, a lot more things with eViews. The only issue is we don't have a license for eViews, so we're only using the basic student version, which doesn't allow you to save your work and is a bit limited. But there are some things we can do on there which we'll cover today. So for the project 2, I'm going to be using RStudio and eViews to do some of the analysis. Okay. All right, so back to this. I just want to cover the things that will be relevant to the final in the project. The last time we talked about the ARIMA process, which was an autoregressive model, a differencing model, and then a moving average model all together. It's a simplified ARMA model, which is just the autoregressive part, the moving average part. And so that would use lagged values of the current time series variable, so like yt minus 1, yt minus 2, going back in the future of the same y variable, or in addition to using lagged error terms. So your forecasting model for ARMA is a combination of using past values and past error terms. So the one we looked at last time also had the differencing part in it. So for this one, you can do the differencing before you want to do it because it's not specifically integrated into this model. But the only difference between this and ARIMA is it doesn't have the differencing. Okay? So there's a nice little section that shows you how to do ARMA models in eViews in your textbook. We're not going to cover that because I like the ARIMA version in RStudio better that we're going to use for project 2. But you are welcome to look at kind of how to construct these models in eViews. We will use eViews for some other things. Okay? So just cover some of the forecasting things. So forecasting in econometrics, so you can forecast a number of things. We're going to try to forecast for project 2 some stock price data for the stocks we chose for project 1. So you can use any number of methods. We're going to use exponential smoothing. We're going to use ARIMA models. And we're going to try to use those models to forecast our stock price might be next month and then a few months in the future. Okay? You might want to forecast tomorrow's return on a particular share, which is essentially what we're doing for project 2. You can forecast the price of a house. You can forecast the riskiness of a portfolio, which would be like forecasting a CAPM or arbitrage pricing theory. Or you could forecast the volatility of bond returns. So any number of financing variables, as long as you have the data, you can forecast it. And the nice thing about forecasting is you really only need data for that one variable of interest. You can employ a number of different techniques to predict what the variable might do in the future based on what has happened in the past. This next slide just shows you that you could, if you want to test the validity of your forecasting model, you could use part of your data, set up the model, and the other part of your data to kind of run the analysis. So it's like, it's essentially forecasting on the data you already have to see how well it performs. So like in this example, you have data from 1990 to 1999. You could use most of the data to run the model, and the last year to see how well the model performs. Okay, so you can use in sample, which is using the data you have, or out of sample, which is actually forecasting what has not happened yet. Okay, so we're using a couple different methods in time series. So that's when we're using the value of a stock for our analysis over time. So we have the stock price, the stock closing price over time for a number of months, and we're going to use that past data to predict what's going to happen in future months. Okay. And the methods we're going to use or focus on are exponential smoothing and ARIMA models. So there's other things, other nonlinear models, other unweighted averages, but the two popular techniques that I want you to use for project 2 are exponential smoothing and ARIMA models, and those are what we'll do in RStudio for your project 2. Okay, so we'll use a combination of autoregression in which we forecast the variable of interest, in your case it's the stock price, using past values of the variable. So you use what happened in the past to predict what might happen in the future. Then you'll also use a moving average process, which is using past forecast errors in typical regression. Okay, those two things would set up your model like this, where your prediction is based on what happened previously to the variable and what happened previously to the error term. Okay, and then how can you evaluate that the forecast is going to be a good forecast or not? So what you can do is do a bunch of different techniques or forecasting methods to compare how well they did to the historical data. So there's a number of metrics, and these are called like accuracy criterion or forecasting errors. You can look at a number of errors like the mean squared error, mean absolute error, or the mean absolute percentage error. And there's actually a number more that RStudio will give you when you do the report. And the idea is that the lower the error, more accurate the method predicted the historical data. So the lower the error, the better, because that means that your model was closer to the actual data. And if that was the case, you can assume it could be closer to the actual data when you predict it in the future. So you want to run a number of techniques. Look for the ones that yield the lowest error, and those would be the ones you're looking for because the lower the error, the more accurate it predicted the data in the past, and most likely it's going to be a better predictor in the future going forward. Okay, so this is not too relevant to this project, but you could also, if you're looking at like daily stock prices, one thing you could look at is like, does it predict the correct sign? So like tomorrow, do you expect the stock price to go up or down? That's a metric you can use if you're just going like very basic. Like if you're not sure what it's going to be, you can at least try to predict: is it going to go up or is it going to go down tomorrow or so on. Okay, so that's a different technique, forecasting the signs. So this one did like 5 steps ahead or like 5 days ahead or something like that. The forecasts, they're all positive, and in this case, two of them were positive in tomorrow, the next day, and so on. And so if you just predict the forecast, the correct sign, like did the stock go up, then that would be correct. And if you predicted it to go up and it went down, then you didn't predict the sign or the correct sign. And so that's a kind of simple way to evaluate, like did I at least predict the stock to go up or down? Okay, so what can and what cannot be forecast? So all of these models are essentially extrapolative, which means you're using data you have to try to predict the future, which has not happened yet. If there's a turning point, sorry, and that means like, is there a recession? Is there a new law that passed? Is there some kind of civil unrest? Or if there's something that you couldn't predict that happens that messes up your forecast, then it's going to probably break down your prediction. Some big structural change or regime shift can't be forecast. Likely in 2019, we didn't predict what happened during COVID, and so since that was likely unpredictable, you can't assume that the models were accurate because that was a big, shock in the system. And just a good rule of thumb is accuracy usually declines with forecasting horizon, and so that means that the farther into the future you try to predict, the more likely it is to be wrong because a lot of things can happen if you keep going farther in the future. And forecasting isn't a substitute for judgment. You're just, using what you have from the past to try to make your best guess. Okay, so this topic is something we're going to do in project 2. And so we're going to to do these analysis, do the normal like ratios and error metrics and look at stuff like that, you want your data to, if possible, be stationary. I covered that a bit last time, but that means that there's no clear trends, there's no seasonal data, and there's no kind of predictive behavior. So if your data is just kind of fluctuates around zero and doesn't have a predictable pattern, I would say that's stationary. If it's not stationary, you would say it has a unit root, and you would have to try to make the data stationary to give it the best predicting power. Okay, so if your model is not stationary, what you can do is difference the series. You can also log the series. So we'll do both, or a combination of both. We will take the log of your series, and we will also difference it, probably difference the log or log the difference, whatever you want to do. So you're going to see that when you look at in test4 your stock to be stationary, it's likely not going to be, because there's usually clear trends in stock prices. If the stock's on a run, it's going up or something like that. And so what you want to do, if possible, is transform your data to be stationary. And the rule of thumb to do that is, first of all, if you do a test and your data is stationary, then you don't have to do anything. But the likely occurrence is that it is not stationary, and that transcribes to it has a unit root. And what you would do is you want to take the difference, or even sometimes the second difference, and try to make it more stationary. So the difference just means that your variable is now the difference between each consecutive period, like each consecutive month. The second difference would be it's like the difference between the difference. So those things sound a little odd, but you're using the same data. It's a bit of a transformation. It really helps to make it more stationary. So what we're going to see is that if you find that your data is not stationary, it means it has a unit root. You're going to want to difference it, or even possibly difference it a second time. Okay, so if the series has a rule of thumb 2 unit roots, you want to difference it twice. It has 1 unit root, you want to difference it once. And so you're probably going to see that when you're looking at your financial data, it's probably going to require at least one difference. And some of the models do it for you, like the ARIMA model will include the difference. But a lot of times your forecasting model won't do that, and you got to do it either before or before the analysis to make sure it's stationary. Okay, so a lot of economic and financial data has a single unit root, and some even has 2 unit roots. So usually when we're looking at stock price data, it's likely that there's at least 1 unit root, which means that your stock price time series is not stationary. You got to make a little quick transformation to make it more stationary. I'll show you how to do that today in eViews. So how do you test for a unit root? There's a nice little defaulter test that we can use. I'll show you how to do this quickly in eViews. And so you can either test if your time series has a unit root, or you can also do a test if it's stationary. I like this one a little bit better, but I'll introduce both types. And so if you're testing for it have a unit root, your null hypothesis is it has a unit root, and the alternative is stationary. So if you can reject the null hypothesis, if your critical value is at least high enough to reject the null, that would tell you your data is stationary. If you don't reject it, you got to do at least one first difference and see it, then test it again, and so on. So this is a simple test, looking at your data set or looking at your variable saying, does this thing have a unit root? If it does, you just have to make a couple transformations to make it more stationary. Then you can also, if it's possible that it does have a unit root, then what you want to do is difference it and test it again, because it's possible that it might have 2 unit roots, which means you need a second difference. You really never want to do a third difference. It's just getting too out there, but likely we'll just the most common occurrence with stock data is that you're going to difference it once, and or take the log and difference that, and that should make it stationary. But usually the stock data is not stationary to start with because there's usually some trend or even seasonality going on. Okay, so that'll make a lot more sense when we do it in eViews, and you'll kind of look at the graph. And then when you make the transformation, you plot the graph, and you'll be like, oh, okay, that's how I see what stationary is. Okay, you could also test if the data is stationary. It's a different kind of test. So in this case, you would test, is the data stationary? That's your null. It says, is it not? So in this case, you'd want to, goal is to not reject it, because if you don't reject it, it is stationary. So just the difference of the way the tests are set up. Unit root, you're trying to reject that it has a unit root, and this test you're trying to not reject the stationary. But either way, you should kind of get the same result. Okay, so I'm going to show you how to do this with your data set in eViews. And that's what we're going to do. And actually, this is, the rest of this is not really applicable to the project, so I'll kind of skip a little section on panel data. I don't think we're going to cover that for this class because it's not really applicable to the assignments I want you to do, and it's not on the final either. So the last 10 slides or so in this PowerPoint, you can skip that. You're welcome to look through it, but it won't be required for the project 2. It won't be required for the final. Okay, so what I want to do next is run through assignment or project 2, and then I'll kind of walk you through how you want to get your data set up, and what you want to do in eViews, and what you want to do in RStudio. Then that should give you enough to kind of do the analysis at least, and you just got to get your data transformed, repeat the analysis for your stocks, and write your little paper for project 2. So if you scroll down to project 2. Okay, so here it's also the same project I put in the top section. So under syllabus assignments, in the very top part of Blackboard, if you open up project 2, this is the second project, which is very similar to the first in the sense that you're going to use some data, you do some analysis, then you're going to write a little 5-page paper. So most students did a pretty good job on the first one, so just kind of spend the same amount of time on this one. I think you'll be fine, but you're going to do a project 2 and submit that by email Sunday, October 15th. Again, you're going to write a short research paper using the techniques learned in class. You can use 1.5 or 2.0 spacing, or even 1.15 if you want. You can make sure you cite, include a references section or a works cited if you're using references. Okay, it's kind of a 3-part analysis. First, you're going to test for unit roots and stationarity. You can use the same 2 stock prices you used for project 1, the formal unit root tests, transform your data if needed to make it more stationary, and get to the point when it's stationary and show the test that confirmed it and then the graph that shows it's stationary. You'll do that for both stocks, and I'll show you how to do that in eViews. Last time we covered exponential smoothing in RStudio, so I'll show you how to do that for your stock data. and you're going to run a bunch of different exponential smoothing models. The best one based on essentially the lowest errors, the most accurate forecast of the historical data, and then use the best model to make your 24-month forecast for bull stocks and bull stock price time series. Then the last part is you'll use RStudio to do an ARIMA model. And this one's a little bit easier because the auto.arima function, which essentially gives you the best ARIMA model for your stock price, you can use that one that's provided for you and run that model. So the whole analysis part is the unit root tests and transform your data if necessary into B stationary. Find your best exponential smoothing model, bull stocks, and then produce the forecast for those. And find your best ARIMA model forecast for bull stocks and produce the forecast for those. And the subjective sections are similar to last time or the first project, and you can have a little abstract, introduce the ideas like what are you studying, what are these, the unit root, what's stationarity, what's exponential smoothing, what's an ARIMA model. If you have any literature or background on these techniques for the stock, which you might have done in the first assignment, you can put that there. Did analysis. So why did you choose the exponential smoothing and the ARIMA model forecast you chose? What are the forecasts? You think they're accurate? Or why not? Just given what you've read about your stock, you're going to put the figures and tables from the analysis part into the final document, and then a little conclusion or summary, and then make sure you have a works cited references page if you use citations or using the outside resources. Okay. So I'm going to show you how to do today. Get your data into the right format. The unit roots, that's for stationarity, do the exponential smoothing, and then do the ARIMA. Then you should be able to do that. Or if you're watching this video later, you can replicate what I do with your stock price and redo the analysis and write a similar style paper like you did the first time. Okay, so your paper should include the figures and tables from the analysis in it. So you don't need to turn in your data sheets or your spreadsheets. Just put all the important stuff into the document that you turn in for your paper. Okay. So the first thing I'll do is actually give me 1 second. I'll be right back. And we're gonna do next in like 2 minutes is we're gonna get the data again for your stocks. And I would like to get more recent data because if you're doing a forecast, you don't want to forecast what's already happened. So I think the stock price data goes up through this month, and so therefore we can try to forecast next month. Okay, so we're going to go to project 2, collect the data, and then we'll do some analysis. So just give me 1 second and we'll do that. So uh, we'll start back here. Then if you have any questions, Hazel, let me know. You can um, unmute your mic or you can post in the chat. But I'll try to walk you through my example, and most of you should be able to repeat it. So what I recommend doing is just recollecting the data because I'd like to have the most recent data because it makes more sense to make a forecast on what has not happened yet. And so I think your project one data got up to like June. You already know what happens in July and August. You can just look at the stock prices. So I think it's better to get more up-to-date stock prices. So if you go to, and if you go back to the project one or you can just Google Yahoo Finance, but the link to Yahoo Finance. So what I'm going to do quickly is just get all the monthly data up to date for my two stocks. You can do the same for your same stocks you chose for project one. Fine. So I did Pfizer. Sorry. Sorry, so I did Pfizer, and you do the same thing as before, except I want you to get all the data, or at least it's not as important that you get the old data, but it's kind of easier just to get everything and go up to date. So you would go historical data for your stock, and right here, time period, you can hit the max button, and historical prices, and change the frequency monthly. Hit apply. Okay, and then you can download the data. Okay, then I'm just going to save this as a separate Excel file and then kind of start working with this one. So I'll just like file, save as. You want to save it as an Excel file or Excel workbook because it's easier. The CSV file sometimes doesn't save your changes. Right, and then you can okay, and I'll just call this FE. I'll save that. Okay, and so the time series analysis, you only want the closing price, but you can have a couple different Excel versions because you want to have a separate one for your RStudio and then a separate one for your eViews. So you just want the closing price, and so what you can do, or what I recommend doing, is delete everything that you don't need. So all you need is the date, um, uh, the closing price, and that's it. So I'm going to delete open, high, and low, and adjusted close and volume. All right, I'll just call this variable um, PFE for the 5 closing price. right? And you most likely, unless your stock is newer, which is actually likely, but your stock should go. Uh, I mean, if your stock's been around for a while, it probably goes from 1985, and then it should go up to September. So make sure you have current data because you can use up to September and then try to predict or forecast what's going to happen in October, November, so on. So use all the data you have to make the best forecast. So the data set for this analysis, bull stock should go up to September, and then you can use all the data you have to make predictions going forwards. Starting with next month. Okay, so just double check that you have data up to September. Okay. Now, we're going to. I'd recommend doing transformations you want to do first in the spreadsheet before you put it in eViews because you could do transformations in eViews. It's not going to save your progress when you close the program. So I'd recommend we're going to do some log transformations, some difference transformations. And I'm going to do those in this Excel file first. So actually, why don't I get the other stock too, put that in this spreadsheet, and then we can use everything together. So another stock would be the Johnson & Johnson one. So J&J, I know is the symbol. Okay. Historical data and max time period or all of the data. Historical prices monthly and apply. And once that refreshes, you can download. Okay, so actually, I'm gonna not actually, but I'm going to put the Johnson & Johnson closing price into the working spreadsheet, so I have them both. So I'll take, I think it's the same time period. It is 1985 to September 2023. So I'll just copy and paste closing price Johnson & Johnson. You would do the same for your stock. Put it in the new spreadsheet, and I'll call this J&J for Johnson & Johnson. All right, and actually, I could save this as project 2. We have project 2, and we'll put it. Okay, and I'll call this only tab. Okay, so you have or should have data for your stocks. Make sure it's the same time period, I guess. But actually, it doesn't really matter because you're doing an individual time series, but you have to keep track of time periods. It's probably easier to do the same time period. So Johnson & Johnson and Pfizer from January 1985 to September 2023. And this is the closing price for each. All right. So what I'll do now is I want to do a natural log transformation and then a difference transformation, and then the difference of the natural log for each. And we'll have that done in the spreadsheet, and then we can upload this eViews and do some of the unit root testing and kind of go through the process of making our data stationary. Then also note that when you do analysis in RStudio, you have to have your data in a different format, which is to have just the data without the dates, just one series in column A. I'll show you that in a second. Or we did that last time, but I'll do it again. Okay. So in your spreadsheet for project 2, you can kind of set up some extra columns. All right, so I have the Pfizer closing price. I want to have the difference. The Pfizer closing price, so we'll call that DPFE. I want to have natural log. I'll call that LN PFE. And I also want to have, if I want to do a final transformation to make it really stationary, I can have the difference of the natural log. So I just call those like the stock price and then D underscore LN underscore and then DLN underscore to be difference natural log and difference of the natural log. And I want to do the same for Johnson & Johnson. So D so difference Johnson & Johnson, natural log Johnson & Johnson, and then difference natural log Johnson & Johnson. And then when you have these all set up, it'll be ready for you in eViews to kind of look at the graphs and do the analysis. Okay, so to do a difference, it's pretty simple. It's just equal to, we did this in the first project, it's just equal to, in column C3 equals 3 minus 2. Okay? So the difference between what happened this period versus what happened last period. Right? And then you can just double click the bottom right corner. And that should apply the difference between each consecutive period. Okay? If you want to natural log the series, that's also pretty easy. So in D3 equals ln natural log of the first one's B2, right? And then you can double click the bottom right corner. That should natural log the whole series. Right? And then if you want to difference the natural log, starting in E3, that's just equal to this one minus this one. So the difference between the first one is November and is September, February and January. So D3 minus D2. Right? And then you can apply that same formula down. That should be all the differences in the natural logs. Okay, and you can do the same for Johnson & Johnson. Okay, so in G3 equals F2, F3 minus F2, the first difference, and then apply that down. Okay, and then to the natural log, you can start here, H2, and this equals ln of F2, natural log of the first Johnson & Johnson. Apply that down. And then finally, the difference of the natural log starting in I3 is equal to, the first one is H3 minus H2. Then you can apply that down. We did all the differencing. We did some of the log transformations, mainly doing continuously compounded burns. We did similar formulas in project one. Okay, and so looks like we have things set up. What you can do is save this. What we need to do is, I think it's useful to save it as a different file with values only. That way we can get rid of the first column. We can't get rid of it now because if we do, then it'll take away the first differences, right? So why don't you, if you're following along here, open up a separate spreadsheet. You can copy and paste all of this data. Just hit like Control A and Control C for copy, and paste it in a blank workbook or spreadsheet. Paste it as options values. Right, so we did something similar in project one where before we did the regression analysis. In that way, these should be all the values. You don't have any formulas, and then, oh, dude, I messed up the date thing, but I can fix that. So let me do that again. Okay, so first, copy and paste the dates. Okay, and then you can copy and paste the rest of it. In my case, it's all the B, C, D, E, F, G, H, and I column, so all that data. Control C. And you can paste that here starting in V1, but paste it as values. Okay. And then you can see how there's some missing values because you got to have at least two observations for a difference. The only thing you have to delete in this analysis is the first one, which is likely January 1985. So let me delete that. And then let me save this. So you have one spreadsheet that's, sorry, I called it project one, but it should be project two. You have one spreadsheet that gets the data, each stock, and then calculates the formulas for the difference, natural log, and then the difference of the natural log for each stock, right? Then you have the other one that just has the values. And if you're doing the same time range, I did it for both stocks, for all the variables, from February 1985 to September 2023. So you don't have, it's likely that it's possible that your stock doesn't go back to 1985 if it's a newer stock. So just use whatever data you have. Make sure both of your stocks at least go up to 9/1/2023. So it's more important that you have current data, not so much that you have all the back data, but if it's there, it's easier just to get it all at once. Name this real quick. Okay, so we got our initial project 2 data set, and you got dates possibly from February 1985 to September 2023, and you have the first stock, difference, log, difference of the natural log, and same for the next stock. And if you got this all nice and set up, you can upload this in eViews and then do some of the analysis. Okay, so okay, so okay. So if you haven't downloaded eViews, you're going to want to do that before the second project. And so if you go to software, Blackboard, and you open up eViews Student Version Lite. So first, you're going to want to do this request page and get a temporary serial number. It only takes a second. Open this up and put in your information, tell them what school you're at, and they'll email you right away a license to use, or a serial number, I guess. And then after you get that, download eViews for Windows, Mac, and when you open it the first time, you got to put in that serial number. It should work. So let me know if there's any issues. I'm downloading that, but it's usually pretty self-explanatory. And if you get eViews up and running, it looks something like this. Okay. All right. So here's eViews 12 student version. Very limited, but I like it for some of the features like doing the unit roots, doing the plots, checking for stationarity. So if you get this program up and running, you get your data set up nice and like we did, you can just do file, import from file, and then open up the Excel spreadsheet with just the values and all the log transformations for the stocks. Project 2. And usually the preset like import options are just default, so you can hit next and next and next, finish, and This doesn't really matter, so you can just hit no. Okay, and then see, it takes a little bit to get working around with eViews. There's way more stuff you can do that the textbook walks you through. We're only going to do some stuff, but I like it for this. And so see how it shows that my data goes from 1985 month 2, 2023 month 9 is correct. There's 464 observations. So I can just double check that that's what I was working with. Right. That's you can't the one of the things about eViews is when you close it, all of your Excel spreadsheets default to opening with eViews. So to reopen a spreadsheet, not in eViews, you have to tell your computer to open it in Excel. So, okay. Okay, so I have data from 1985 to September 2023, 464 observations, right? And that's what I got here. So eViews is pretty smart. It should know what you're importing. It should put it in the appropriate range, but just double check that the range is correct and the correct observations are there. So what you want to do for this part is you can look at a plot of your data. So here is each variable listed individually. All right. I can open up Pfizer. I can do the graph, view, graph, and you could just go with the default and hit OK. Right, so there's my Pfizer graph. A nice little graph it makes for me. But you can probably see that it's not stationary because there's some trends, upward trend, downward trend, and just like an overall upward trend. But you can test formally if you have a unit root or not, and it's pretty easy. So what you would do is do unit root tests and standard unit root test. Now you can leave the defaults, but I like to change the lags 12 and hit OK. And so it does the test for you. So here's the null. It has a unit root. Here's the Dickey-Fuller test, 1%, 5%, 10% levels. And here's your test stat. So your test stat has to be bigger than these critical values, absolute value. And you can see that it's lower. So it's not significant at any level, which means the time series has a unit root. It's not stationary. So what you'd have to do is do a transformation to see if you could make it stationary and then run the test again. So just as a normal time series, not stationary. And again, I'm looking at this t-stat and comparing it to the critical values. If this is not bigger than these absolute value terms, you can't reject the null. You can't reject the null. And therefore, Pfizer has a unit root. It's not stationary. Okay, but I've already done the transformations, and I can now check the difference. Pfizer, here it is. Okay, so here's the graph. Looks a bit more stationary. Actually, I wanted to show you the log first. So log of Pfizer is this one. Here's the graph. Okay, so it looks like it's be a little. It takes out some of the fluctuations, but still looks like it has an upward trend. So my guess is just doing a log transformation didn't eliminate the unit root, and it's still not stationary. So let's double check the tests. Do unit root tests, standard and change this to 12. 2.3, so yeah, actually no, it didn't. So this, and again, we're looking at absolute values, so just 2.3 is less than all the criticals. So we're not going to reject the null. And just doing the log transformation wasn't enough. It's still not stationary. All right? We have two more options. I'm pretty sure that one or both of these will be stationary because I've done this analysis before, but how about the difference? Pfizer. So there's our graph. See what I mean by stationary? Like it kind of fluctuates around a mean zero and doesn't have a really predictable pattern. And it does look like the variance changes a bit, but this is what you'd want. This is what a stationary time series would look like. Something that fluctuates around zero and doesn't have any pattern. It kind of looks like a radar or like white noise. Let's check. Does the difference of Pfizer have a unit root? Is it stationary? Yeah. See how the critical value is 17? Absolute value is much bigger than the 1%, so it can reject this one at the 1%, and you're very sure that there's no unit root. You can reject this and conclude that the difference of Pfizer is stationary and there's no unit root. Okay, that's the results show you there in the test and also in the graph. And I could even do one step further and see if I can get even a higher t-stat than 17. I looked at the difference of the log of Pfizer. Look at that. That's like, I mean, this is how you draw. This is how you would like say does a stationary time series look like. This is it. It just jumps around zero. The variance doesn't change much, and this is exactly what you'd like refer to as like a textbook stationary picture. So let me check my results. There you go. So doing the difference wasn't enough. Sorry, doing a log wasn't enough. Doing a difference did enough to make it stationary, but often the best or most stationary would be differencing the log. And look how much bigger the t-stat is. Like it's 21, bigger than, much bigger than the critical value. And so likely doing a difference of a log would be the most stationary transformation of your series. So what you want to do for your project is go through this process. Say like my data wasn't stationary at first, if it wasn't, did this transformation and so on. It just kind of, you don't have to put all these graphs and tests, but do put in like the final test, the final graph. So if you're going to show that this is my most stationary time series, you would include like a picture of this test and then include this graph. Okay. So just describe the process, but you only have to include in your paper one root test, one graph for each stock. Okay, and also make a note that you're going to want to make sure you save like screen caps or pictures because this is the student version of eViews. So when you close it, all your data is going to be lost and all your analysis will be lost. So when you open it again, you have to re-import the data set and redo the analysis. So I'd highly recommend if you do some stuff in eViews, screen caps, or do whatever to make sure you save your pictures, tests, because when I close it, it's going to ask me actually, before I close it, questions on the eViews part, because when I close it, it'll lose all our progress. All right, so that's one of the parts. Okay, so for project 2, you can do that process to go through the formal transformation and tests, transform your data into a stationary time series, and then kind of do that for both stocks. So that's the first part of the analysis. You would do that in eViews. So I'm going to close this. And you'll note that it'll say like save. You try to hit yes. It'll say it's like it messes with you. It's like can't save in the student version. So I don't even know why they asked, because you can't save it, but you know, close it. You can't save it. Hit no. And then if you want to redo eViews, you gotta open up the program again and then reload your data. Okay, and then you want to do exponential smoothing, and you would do that in the RStudio part. Okay, so I mentioned last time that you would want to under software, and we did some RStudio last time. If you haven't downloaded RStudio, just you want to do this before the project. You would want to, under software on Blackboard, download either R for Windows if you have Windows, or R for Mac if you have a Mac, depending on what you're using. Then after you do R, do that first. Download RStudio, and again, it's free. It should take a few minutes or maybe a little bit longer, but really useful software for doing time series analysis. So you'll need this platform and eViews platform to do the analysis for project 2. Both are free. Both are relatively easy to install. Okay, so that brings us to, if you go to project 2, I put some examples of the way my data files, and then look here, Excel. Here's the assignment again. The important thing is this, the project 2 code text file. Okay, so under project 2 on Blackboard, project 2 code.txt. All right, and this will open up basic coding to the analysis for exponential smoothing and then for Riemann. Okay, and I'll walk you through that. I set the code up where you can put in put in what you have to input, like your data set and your year, month. All right, so most of this you just use the same program, or not program, but command, and change a few things. I'll show you what to change. You use the basic template for the command, and then change it to match your data set, and then that's all you have to do. So what I recommend is open up this txt file and save it, and then you could add your modifications and just save the text file in so if I right click this, save as, I want to save it as txt file. I'll save it as project 2. Okay, and then When you go back to open it, you probably have like a default text reader. Open a text file. I'd recommend you can um, you could just use like Notepad. I like to open with Notepad. Okay, and that way, see like what I'm doing here. If you open it with one of the Notepad text file readers, you can make changes to it, and then open it back up to reflect the changes. So this part, actually, let me do it first. Okay, so first, I want to download and open up RStudio. Okay, so it looks like this when you open up RStudio. All right, and then if you haven't done so from last time, you'd want to activate the package that goes along with the forecasting textbook we used last time. And so your packages install. The software package we're using is called FPP, Forecasting Principles and Practice. So if you haven't done that, just follow this step. Then go to packages here, install, type it in, FPP, and just hit install. Okay, and then that should do it for you. All right, and then this thing, require FPP, will load the package. And so the reason why you want to do this is because there's thousands of different packages you can use in RStudio, and you want to just specify which one you want to use right now. So tell RStudio, I want to start using forecasting FPP package, and until you tell it otherwise, it's going to use that package because specific commands that go with just this package. So you copy and paste, require FPP to the console and hit enter. That should good for you. If you get some little red errors, it's fine as long as it goes through. Okay. Then what you want to do is put your data into time series format, and then upload it into RStudio. So what am I doing next? All right. Okay. Okay, so here's the project 2 one we started. Okay. So I'd recommend saving this a separate one for each stock. So I'm going to have one for Johnson & Johnson and one for Pfizer. I'm just going to save it as something else. File, save a copy. I'll just call this, for RStudio, I recommend having a very simple, maybe lowercase name for your data set because each time you call for it, it's going to be, it makes it more complicated in your coding if your data set's like Pfizer XE 2000, just make it very simple. I recommend just going with like lowercase version of the stock price. I'm just going to call it PFE. Okay, and the only data you want to upload in RStudio is stock price for that stock. So For this one, I have this data saved in the other spreadsheet, but I'm going to delete everything except for the closing price. Okay, even title. All right, so see how the format is supposed to be? Just in the A column, you have the closing price all the way down to the most recent observation, and that's it. So nothing else labels the data in the A column. And everything you do with it, you'll tell the RStudio to do it when you upload it. Okay, so here's the format. You want this format for both docs, but I'll just do it for this one for an example. Okay? So I got it set up like I want. Okay, now we'll go back to RStudio like this. Here we got the program running, and we can just simply upload the document file, import dataset from Excel. Just let's find it first. And the only option I want you to check is where it says first row is names. Actually, uncheck that. And then everything else you could leave is the default. Hit import. You should see the data set up here with just the values for the closing price and nothing else. Okay. So here's how the RStudio works. Here's your data up here. Here's the console where you type in commands. Here's the area where you get like plots. And this shows your variable definitions and the history of your Excel or commands. Okay, so first thing you want to do is, again, you want to download this TXT file as a text file so you can edit it. Then when you download it, it looks, here it is, Project 2 text document. I recommend opening it, open with whatever notepad reader you have, so that way it saves it. Okay, and we did this part, right? And this is the command to convert your data into a time series. So you go through and change the things that match your data set. So when it says data, type in the name of your data set. My data set's called PFE. Whatever your data set's called, replace data with that. So data should be PFE. The rest, PFE. Start here is 1985. End year is 2023. End month is September. I think this was February. Let's double check. And as you're making changes, just hit save and it'll save it for you. Okay, so see, like when I close this, we open up the Project 2 text document. It should save your changes. And you can the reason why you want to save your changes is because you can just copy and paste it later and not have to change the things again. Okay, but let me just double check the range. So, Yeah, February 1985 to September 2023. Okay, so see how that start date is year, comma, month, end year, comma, month. Frequency is 12, which means you're using monthly data. Once you get this command set up, just copy and paste it into RStudio. There. Sure. All right, and that should convert the data into a time series for you. And nothing happens, but as long as you don't get errors, that the assumption is that you did it correctly. And to double check, you can plot your data. So plot, again, this is not data, it's your data name, which in my case is PFE. Okay. So let's plot it. Type in the command, copy and paste, enter. There you go. So it should give you a nice plot of your time series. Okay. And you might even want to double check that, like when you go to Yahoo Finance, a little graph here, and if you click on max, just double check that your graph looks similar to the one that's on Yahoo Finance because you're using the same data. You know what I mean? Yeah, see, that looks good. So it looks like mine does about what happens in the data set. So that looks good. Okay. And then back to RStudio. The first thing you want to do, last time we introduced all the exponential smoothing models, and that's in the last video if you weren't here last time. But these different types are all the different fits we discussed last time. So what you can do is just first of all put in change your versus data in your data name. So mine's PFE. Okay, so we went over at least 7 types of exponential smoothing methods last time, and we're going to use those different methods to do a forecast with your data. So try all these methods, and you can see which one is the best fit by looking at the lowest error for accuracy. Whichever one is the best fit, that's the one you want to use for your project. Okay, so the first thing is you can try all these methods. You're gonna have to delete the little tags, but so you can either do them one by one, or you can copy and paste the whole section like this. But make sure you take away the little reference tag here. So that was simple. This one's for Holtz. This is exponential. And this is additive damped. This one is multiplicative damped. This is seasonal additive, Holtz Winters. And this is the seasonal multiplicative. Okay, so you're trying 7 different fits of versions of exponential smoothing. And again, make sure you have all the coding like this. Take away the reference tags. H equals 24 means a 24-month forecast, so 2 years. And make sure where it said data, you change your data name to be the name of your data set. And you can do all these at the same time, hit enter. There it goes. Looks like it worked. And then you can compare the accuracy of all the fits, and each fit goes along with this. So fit 1 is simple exponential smoothing. Fit 2 is Holtz Winters, Holtz linear trend. Fit 3 is exponential trend. Fit 4 is additive damp trend. Fit 5 is multiplicative damp trend. Fit 6 is Holtz Winters seasonal additive. And fit 7 is Holtz Winters multiplicative additive. Right? And so if you type in all these, take away that little hashtag reference, but you're comparing the accuracy or the errors of all the fits. Okay, so this is a bit tedious, but what you want to do is make a little, you can either do it on a piece of paper or make a little spreadsheet and go through and see which fit gives you the lowest errors, like on average. I'll show you like a little example. So Johnson & Johnson formulas. Okay, so see what I did here is for both of the stocks, I made a little spreadsheet. So here's all the different fits. You want to go through and see which one has the lowest error for each of the categories. So this is the mean error, mean squared error, mean absolute error, mean percentage error, mean absolute percentage error, and then mean absolute squared error. And then I don't know what this one is, but it's another error. So see how like 2 is the lowest in this section, 7 in this section, this metric, and see how I like tallied up. Like fit 1 had the lowest of just one of the categories. Fit 2 had the lowest of one of them. Fit 3 didn't have any low fits. Same with fit 4. Fit 5 had the lowest 2 times, but fit 7, at least for this one, it was the lowest in 1, 2, 3, which was the most. So you kind of want to go through and see which fit gives you the lowest error measures on average, and then whichever one it is, it's recommended that you go with that one. Or if it's a tie, just kind of pick one. Normally you have a clear favorite. If you see what I mean, I'm just like looking at all these measures of accuracy and seeing which one was the lowest in each category, and then whichever had the most lowest like wins in the types. This one had 3. We can go with that one. Okay, and if you do, you can show this little spreadsheet in your paper to show how you came across your decision. Okay, so the point is that if I did the analysis and decided that fit 7 my best one. I would plot Fit7 and not the other one. So these options for forecast plots, only plot the one you're going with. You only need one plot. So you fit them all, you compare the accuracies, then you pick the best one. If it turns out to be Fit7, I'm going to plot Fit7. Yeah, so there's forecast from Holtz-Winters, which is a seasonal method. And so this little blue, here's my data. This little blue squiggly dark line, that's my forecast 2 years going forward using this method. If you want to see what those numbers are, you probably should. Just type in, so if I'm going with Fit7, type in Fit7, hit enter. It tells you what your forecasts are. So like it predicts that Pfizer's closing price October would be 33, November 34, and so on. So stay in about the 30 and go down a little bit. So these are the actual best guess forecast numbers for your closing price, or for my closing price for this from this method. Okay, so you'd repeat that analysis for both stocks and pick your best exponential smoothing based on the analysis, and kind of report the graph from whichever one you chose. Okay, and then the last part would be to do the ARIMA part for both. And again, I'm only doing an example of one of my stocks, but you want to do all these analysis for both of your stocks. Okay, so let me show you this one. All right, so here's ARIMA, and you can do there's a auto.arima function which tells you the optimal model to use. So once you just type in, let's do this one first. So data should be, oh, sorry, PFE. So change your data to be your data name. And you can save this text document so you can come back to it later. So the command is auto.arima. Then your data name, comma, seasonal equals false. Put that in here. All right. So it tells me that my optimal non-seasonal model is 0 autoregressive terms, 1 difference, and 2 moving average terms, which are the previous forecast errors. Okay? So I can then use this suggestion and run that model. So I'm going to do fit ARIMA. This is PFE. And I want to specify my order based on the results, which in my case is 0, 1, 2. Right, and this will depend on your auto.arima results. But here's the one for mine. Okay, I fit that. So I can plot it, and this is plot forecast fit it 24-month forecast. This part where it says YLab, that's the name of your stock. So where it says ABC stock, you can just put in the name. So this is Pfizer. and do that. Save. There we go. All right, so there's my forecast. Here's the historical data. There's the forecast from the ARIMA, 012. Right? And the last thing would be to check seasonal ARIMA, if possible. So I would fit 9, ARIMA, and your data name. Sorry, first I'm going to hit it. Okay, so you do auto.arima, the name of your data set. Okay, and it looks like it gave me, this time it gave me still 010. It might give you a seasonal model, and if it does, you can specify that. With like fit9 is ARIMA, and then this is the non-seasonal part, and this is the seasonal part. If applicable, change the numbers here to be whatever you got in the results. In my case, I'm just going to fit fit9, which is this, but change the order. So fit9, ARIMA, PFE, order is 010, which is just the first difference. There's no seasonal part suggested for my model, so I'm going to delete this part. Okay, so it's fit9, ARIMA, PFE, order 010. Okay, so I'm going to try this one. Okay, and then I want to see what that one looks like. But this should be Pfizer. Okay, there we go. So I have one option for the 012, the other option for the 010. Okay, again, this one is just a first difference. Okay, we can see which ARIMA model is better, looking at the accuracies. Fit8 or fit9. You'd have to go through and get the numbers, see which one's lower. I can't really tell off the top of my head, but it looks like this one's lower, this one's lower, this one's lower, this one's lower. Yeah, it looks like in like every case but one, fit9 was the better one in terms of having most cases the lowest error, meaning it fit the historical data better. So I'd go with that one. I'm going to go with fit9. And so I'll do forecast fit9 H equals 24, which is a 24-month equivalent to a 2-year forecast. There we go. So here are the point forecasts, which are just 32.1. So I guess that's the The thing is, see, that's why it's like the stock behavior of Pfizer. Like it went up, went down, went way up during the vaccine development. It's gone down recently, so this is saying we don't know what's going to happen. It's been going down, but we think it's going to keep going down. Who knows? So it's not entirely sure what's going to happen with this stock because it's done some weird stuff in the past few years, like gone up, gone down. Going to happen. But here's my ARIMA model, just a difference, and here's the graph, and here's the forecast. So you should be able to modify this text document and you can save it. Okay, and that way we open it back up. You should have all your changes saved. Okay, so I'm sure that there's going to be some questions on the project too, but that's the gist of it. We covered roughly all the material for project 2. We covered exponential smoothing and ARIMA last time. We covered unit roots and stationarity this time. And you need to do the analysis, gathering your data, and doing some of it in RStudio, I just showed you. And the first part in eViews, which we did with the stationary tests and unit roots. Okay, and so project 2 included in project 2 instructor figures and tables. This is an older version, but you get the idea of things you might want to include. Okay, so I put one test for each, or just the final test. If you're going with the difference of the log, which is likely your best outcome. It might not be. It might just be the difference, but show the results from that test, each stock, and then show the graph of how you made it stationary. And the same for the other stock. So here is the difference LN Johnson & Johnson, and here's the transformed, much more stationary graph. Then you want to include the table that shows why you chose whichever fit in exponential smoothing, like whichever one had the lowest error overall, a graph from that one, and then the point forecast, and also for the other stock. Then show the ARIMA process for each stock, how you got the ARIMA you chose, graph you got when you ran it, and then the accuracy metrics. You can show that, and then also the forecast from the ARIMA, and then the same thing for the other stock. There's my ARIMA auto forecast, accuracy, and the results. So obviously you don't want to make your paper 18 pages. It can be a bit longer than the first one because there's a lot more tables and screen caps. So don't worry too much about over the limit, but it doesn't need, I'm just showing you examples here. It's likely your paper could be with all these tables, 10 pages, because at least half of that is just showing the results and the graphs. So okay, so I think I'll give you enough to get started on project two. Um, we can do some more on project two if students have questions for our last meeting, as well as talk about the final, or if you can't make any meetings and need additional help, we can try to do office hours at some time with the Zoom meeting. But I think that gives you enough to comprehend the material, download the software programs, enter data in the right format, and then start doing the analysis. And you still have a couple weeks, but don't have to wait to the last minute because I'm sure you got other stuff going on. You have the final exam, only a few more weeks of the semester, the fall term. Okay, so I think that's what I want to cover for tonight. Do you have any questions on that, Hazel, before we wrap it up? Oh, okay, no problem. Um, okay, all right, welcome. So thanks for joining. And I will, those of you that couldn't attend, I'll save the video and post it to YouTube. Then you should be able to find it at the same place. So I'll get that uploaded. And thanks for joining. And I'll set up our last meeting at some time. But let me know if you have any questions on the project too.